All right, let's talk about finding arc length. Arc length on a circle, you've got what's called a central angle here. The angle is centered in the middle of the circle, and what we want to do is figure out how to find the arc length here. Now I've got it listed here as s, and that's typically the variable that's used for talking about arc length. Same way r is used for radius, theta is used for angles. You tend to use s for arc length. And here's the formula for it. S is equal to r times theta when theta is in radians. So this formula, I'm just kind of giving it to you here, and it's based off of the definition of radians. But there's another way you can work this out. Think about it like this. The circumference of the circle is 2 pi r. Or pi times the radius times 2, or pi times the diameter. And if you look at this, if theta is in radians, what you do is you take the circumference, then you multiply it by the fraction of the circle you're looking at. So if you're only looking at theta, and that's out of 2 pi for going all the way around, the 2 pi's cancel, and you're left with r theta. So that's where this formula comes from. So I want to do two quick examples with this. Find s here. All right, s is equal to r theta. So that's equal to 8 times 5 pi over 6. So 8 times 5 is 40. So this is 20 pi over 3 for the arc length there. Okay, now this other problem is we're going to use the same formula, but we're trying to find theta in this case. S equals r theta. S in this case is 30 millimeters. R is 42 millimeters. So theta is 30 over 42. And let's see, we can divide both of those by 6 and we get 5 over 7. So my angle here, theta, is 5 over 7. Now that's 5 over 7 radians. If you wanted to convert that to degrees, it asks, find this in radians and degrees. So you take 5/7, and you multiply that by 360 degrees over 2 pi. And let's just get this as an approximation. 5/7 times 360 over 2 pi gives me 40.926 degrees. Now, when I drew that up there, I don't really know if it's to scale or not. But anyway, that's the angle in degrees. All right, let's do one more applied problem here. Let's see. Pac-Man has a radius of 20 millimeters and his mouth makes a 55-degree angle. Find his perimeter and round it to the nearest tenth of a millimeter. Let's see. All right. Here's what I would do here. If you look at Pac-Man, his perimeter, it's equal to his circumference. Or actually, there are a couple things we could do. We could do the circumference plus twice the radius, because you gotta account for this and this, and then subtract out the sector. Another way to do it would be, let's talk about this as our sector. So in this case, the theta that we're going to use is going to be not the little angle, but the big one. So that's going to be 360 minus 55. So that's going to be 305 degrees. All right. So this length is going to be, well, here's how I would do it. Let's call this S, R, and R. So it's going to be S plus 2R. Now S, let's find it. That's going to be, here's how I would do it. It's 2 pi times the radius. Now that would get you the entire circumference of the full circle. But what I would do is I would say 2 pi times that, and then the part of it that we're interested in is 305 degrees of the 360 degree circle. So let's see, 305 over 360 equals that, times 2 times pi times 20. All right, this gives me 106.465. And 2R is going to be, let's see, the radius is 20, so 2R is 40. So if you add this up, the perimeter is going to be 146.5, because it did ask us to round to the nearest tenth of a millimeter. So Pac-Man's perimeter there is 146.5 millimeters. All right.